Hey guys, how's it going? Today I'm going to be going over 10 common math mistakes and how to avoid them. So, I've made pretty much all of these mistakes throughout my career um, doing math, and I want to share them with you today in the hopes that you'll recognize them when you're doing your own work and be able to avoid doing them. Um, so, the first we're going to start with is possibly the most common mistake. It is a plus b squared. So many people think that a plus b squared, they're rushing quickly through their work and they're just going to say it's equal to a squared plus b squared. This is very incorrect. This is one of the biggest mistakes that math students make when they're rushing through their work. And if you just consider it as a plus b times a plus b, you can easily recognize that you have to distribute each term. So it becomes a squared plus ab, a squared plus ab, plus ba, which is also can be written as ab, plus b squared. So it's a squared plus 2ab plus b squared. And I've made this mistake many times, but you just have to remember this 2ab. And if you think of it as multiplying these two terms in parentheses together, then it makes it much easier to visualize. The second most common math mistake that I've made is forgetting to distribute the negative when you have a bunch of terms. So these mistakes may seem easy to avoid right now, but when you're dealing with complex expressions and there's a lot going on, it's easy to make this minor mistake that will completely change your whole answer to the question. And here again, we just have to distribute the negative, so it becomes minus a minus b. This one's a quick one, but if you have a lot of terms in your expression, it's very easy to make this mistake. So the third one is just a general tip, and it's just keeping your work organized and clear. And what I mean by this is that if you have, say, an expression with a ton of terms, like x to the fourth minus 4x cubed plus 3x squared plus 1 over x to the fifth plus 6x cubed plus 2x plus 10 or something like that, and you are multiplying it by x squared plus 1 over 3x, or you just have any sort of complex equation like that, you want to keep your work organized and clear. You want to have space to think about the problem clearly and process it well. So, what I usually do if I'm struggling on a really hard question is just to repeat the beginning of the question or the step that I'm stuck on a completely blank piece of paper, because the more blank space you have, the more clear your mind is, and the clearer your space, the better you'll be able to think about the question instead of being cluttered up by all these random terms. Another general tip is to follow the equal sign. So if you're trying to prove that one thing is equal to another thing, say x squared is equal to x times x, for example, and you are trying to prove that these two are equal, you're going to want to keep your equal signs consistent through every step of the proof. Obviously, this is a very simple proof, but if you have something very complicated, it's really easy to organize your work by just following this equal sign downwards and trying to get to the end of the proof like that. And it helps, going back to point 3, keeping your work organized and clear. So the next tip is to is when you're adding fractions, 1 over a plus 1 over b, it could be a half plus a third. It is not equal to 1 over a plus b. So that's a mistake that a lot of people make, including myself. And you can just think about it in terms of normal numbers. So a half plus a third is obviously not going to be a fifth, but this mistake is more hidden when you have 1 over x squared plus 1 plus 1 over 3x. It's not equal. It's tempting to think that it might be equal to x squared plus 3x plus 1, but in reality, this is not the case. And you can always just go back to the example of numbers and see that a half plus a third is clearly not a fifth. Another mistake is with complex numbers. So if you have 3 over 2 minus I, for example, you never want to leave the I in the bottom. Never leave I in the bottom of the expression. Always multiply by the complex conjugate, which is just the minus of the term with I. And that will help. You never just want to leave the I in the bottom. So that's a good way to avoid it, is just multiplying by the complex conjugate. Another general tip, number 7, is to know your professor's preferred notation and stick to it religiously. So if in class your teacher decides to use I instead of J, or phi instead of theta for angles, just know which one that your professor prefers, and that will make it much easier when you're doing problems. You're kind of putting yourself in the shoes of your professor, who has most likely made up your homework assignments and your exams, and it'll make it so much easier to think through a question when you're thinking through the lens of your professor and the notation and style that your professor wants. The next goes hand in hand with organized and clear work, which is constantly labeling your work. So if we have a graph, for example, you'd always want to specify x and y, or real and imaginary, just to make it clear to yourself and to the people who might be reading your work that you understand the material and you understand what's going on. That's going to make it a lot easier to work through your logic and make sure that for yourself as well that you understand what's going on in a problem. Another way that you can label your work is to make it clear what problem you're solving and how and what the end goal looks like. For example, if you have a proof, you are going to want to make it clear to yourself and whoever's looking over your work that this is a proof. So you would start out by writing proof, and then maybe by induction or whatever method you're solving the question. And by doing this, you kind of make it clear to yourself what mindset you should be in and how you're going to deal with the question and how you're going to tackle it. And the last common math mistake or advice that I can offer is when you're dividing complex systems. So say you have a plus b over 2a divided by 3c over 12. You're going to want to always kind of switch to multiplication. So you might reach a point in the question where instead of looking in this easy fashion where you know just to flip the other side and multiply, you might be in a situation where you have a plus b over 2a divided by 3c over 12 or something like that, where in your work you may accidentally stumble upon this complicated expression, and what you want to do is kind of just make it clear to yourself what the terms are on the top and bottom and kind of go through, try to get it to this simple format in the end here. Okay, so thank you so much for tuning in. I might do another one of these videos with more math mistakes, maybe related to geometry or calculus. But thank you so much for listening, and I hope you learned something today. Bye.